Okay, Math 8 students, we are on to lesson 5.2, writing linear equations from a table. So our essential question for this lesson is, how do you write an equation to model a linear relationship given a table? In the previous lesson, we were writing linear equations, that's y equals mx plus b and y equals mx, in using graphs and using situations. So this time we're going to go ahead and write linear equations using data from a table. So we're going to jump into example 1, which is graphing from a table to write an equation. So what we're doing here is we're connecting the previous concept. We're taking a table and we're creating a graph, and then from that graph we can create an equation. So let's look at what it's given us here. The table shows a temperature of a fish tank during an experiment. Graph the data and find the slope and y-intercept from the graph. So then write the equation for the graph in slope-intercept form, and that's the y equals mx plus b. So we've got our table of values here. Our top value is going to be x, and our bottom value is going to be y. Remember that x is our input, and y is our output. And that means that y depends on x. Our input determines what our output is. So at 0 time, we have 82 degrees. At 1 hour, we have 80 degrees. So it shows the temperature and it shows the number of fish. You put in the time, you get out the temperature. Sorry, not number of fish, temperature over time. So what we're going to do here is we're going to create a graph first. And so I'm just going to draw my x and y axis. This is my x and this is my y. And I already know that my x here is going to be time in hours. And then my y is going to be temperature in degrees Fahrenheit. And I'm going to look at my range here for time, which is 0 to 5. So I'm starting at 0, and I'm going to go ahead and go probably up to 5. 1, 2, 3, 4, 5, 6, because I have space. 1, 4. So that's based on the range that I have. So that's just why I'm using those numbers. And then I'm going to look at my range of temperature for my y-axis, and my highest is 82, my lowest is 72, so I need to get up to that. I think I'll probably use count by tens maybe. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So 20, 30, 40, 50, 60, 70, 80. Okay, so it's not going to be a perfect graph, but it's going to give us an idea of what we need. So from my table, I can create ordered pairs, which is how I graph. And some of you guys don't need to write these separate, but I'm going to go ahead and write them out because some of us it's helpful to see these turned into a set of ordered pairs. And remember that x is always first, and then y. So my first ordered pair would be x is 0, y is 82. My next pair would be x is 1, y is 80. Let the bell go. And then 2 and 78, 3 and 76, 4 and 74, and then 5 and 72. So I'm going to go ahead and graph those points. And you didn't have to write those out, right? You don't have to write those out if you can just pull the points from the table, but some people have to write them as points before they can convert them to points on a graph. So let's go ahead and create those points. So that first one is 0 and 82. So that's going to be right about here, above 80, because this is a range of 10. The next one will be 1 and 80. Then 2 and 78. So we've got a slight negative slope going on here. 3 and 76, because if this is 70, it's going to be about, halfway in between there. 4 and 74, slightly lower. 5 and 72. So this is a really pretty shallow slope, right? That's about 70. Okay, so now I'm going to connect my lines because it's temperature over time, so I can connect my lines because I can determine a temperature at any point in time. Okay, so now that I have a graph, I can determine my equation in slope-intercept form. And remember, that's y equals mx plus b, where m is our slope and b is our y-intercept. Okay, so what is our slope in this? If we pick 2 points on the graph, which is what we were doing, I'm going to go ahead and pick this point right here, which is 0 and 82, and I'm going to pick my last point right here, which is 5 and 72, and I'm going to read from left to right. So this is my x1, y1, x2, y2, and I'm going to use that formula, m equals y2 minus y1 over x2 minus x1, to determine my slope. So my x2 is 72. Sorry, my y2 is 72, my y1 is 82, so minus 82. My x2 is 5, my x1 is 0. So I've got 72 minus 82, that's negative 10, over 5, which simplifies to negative 2 over 1. And in this case, that means 2 degrees Fahrenheit for every 1 hour. So it decreases at a rate of 2 degrees Fahrenheit per hour. And so that's my slope. And then my y-intercept is just going to be the point where my line crosses the y-axis, right? So here we go. I'm going to look at my y-axis. I'm going to see where my line crosses, which is this point right here again. And so it's my y value when x is 0. So b equals 82, which is my initial value, right? That's the number that I start at in this case. So I've got b, I've got y. I can plug these in, and I've got y equals negative 2x plus 82. So for my fish tank, it starts at 82 degrees, and then it goes down 2 degrees every hour, which represents our output, our input, right, our time in hours. And that's going to give us our output, which is our degree in temperature. So starting at 82 degrees, decreasing 2 degrees per hour. And so we can use this equation to find out at any time what is our temperature going to be. Okay, so what we did is we used a table, we made a graph, and then from what we learned the past couple days, what we've been practicing the past couple days, we used the graph to determine our slope and y-intercept. So let's see if we can just go ahead and find the equation without having a graph. And so that's where we're going to come here to example 2 and determine our equation from just a table. And we can do that. You guys can do that. You totally got this. Because this is very similar to how we got information from, how we got an equation from just a scenario, just a situation yesterday and the day before. So let's read what we got here. Elizabeth's cell phone plan lets her choose how many minutes are included each month. The table shows the plan's monthly cost, Y, for a given number of included minutes, X. So write the equation in slope-intercept form that represents the situation. So once again, we are given our X and Y, right? So this is going to be our input. Oops, it already tells us X. This is input, and this would be output. So we put in a number of minutes included, and that gives us the cost of the plan in addition to if there's maybe a starting value, right? So we need to find, for our equation, y equals mx plus b. So we need to determine our slope and our y-intercept. So the first thing that we're going to do here is we are going to pick 2 pairs of values from this table. And if we look back here to this first example, that's exactly what we did up here, right? We picked 2 pairs, which if we look, that was this pair here and this pair here. So we don't even need to graph, right? We can just pick 2 pairs of values from the table. So going back to this one. Because what that's going to let us do is it's going to let us determine our slope with y2 minus y1 over x2 minus x1, which is our change in y over our change in x. So which 2 points? I'm going to go ahead and just pick these 2 right here. They seem easy. So this is my 1 and this is my 2. So my x1, x2, y1, y2. And I'm going to plug those in. So y2 minus y1 is 20 over 14. And a common error here is that we would put our x's on top, but make sure you put those y values on top. So 20 minus 14 over x2, which is 200, minus 100. So 20 minus 14 is 6, and 200 minus 100 is 100. Okay, so I could leave this as a fraction, but I can also pretty easily convert this to a decimal. This is 6/100ths, so that would, as a fraction, be 6/100ths. And I converted it to a decimal because we're talking about money. And so this is my, this is a value in dollars, right? This would be 6 cents. So this means that 6 cents, right, is my cost per minute included. So we've got M. Now how do we find B? We have to think about what we were doing in our previous lesson where we had our equation, y equals mx plus b, and we plugged in our m value, right? So then we did, in this case, y equals 0.06x plus b, and then we're going to pick an x and a y value. So any two values from the table. I'm just going to go ahead and pick these right here because it's just the first one and it's easy enough to plug in. And I'm going to plug those values into my x and y. So now I have 14 equals 0.06 times 100 plus b. And here we've got our inverse operation practice. So now what I can do is I can use my inverse operations to solve for b. Okay, so 0.06 or 6/10 times 100 is 6. I bring my 14 down, and I've got my plus b. So now I'm solving for b again. So my inverse here is addition. My opposite would be subtraction. I'm going to subtract 6. That cancels 6 out here. And I've got 14 minus 6, which is 8. So b equals 8. So now I've got both my m and my b value, and I can plug these into my equation. So I've got y equals 0.06 or 6 cents, in this case because we're talking about money, x plus 8. So what does this equation mean in the context of this situation? Well, her cell phone lets her choose how many minutes are included each month. So that would be x, right? So she gets to choose x, and it costs her 6 cents per minute plus $8, right? So that could be like, okay, no matter what, you have a monthly fee of $8. And so that's going to give her total cost of the plan. And this is a real world situation here. Most of you guys have cell phones or have, some of you even pay for your own. So this would be like the monthly fee, like no matter what, she has to pay this much per month, $8 per month, plus 6 cents per every minute that she includes in that plan. And that would give her total cost. So input x, output y, multiplied by our slope, add our y-intercept. Okay, so I'm going to have you guys, if you want to, you can go ahead and stop here as far as watching the video. If you turn your page over, there is 3 practice problems, 3 your turn. And you can do these on your own. I had these in previous ones, I had these mixed into the lesson, but I think that what I'm going to do is have you do these on your own. And you can watch the video if you need more practice and do these with me, or you can stop, try doing them on your own, check your answers in fast forward, and be done with the notes. Okay? So you got the examples here, example 1, example 2. That's the nitty-gritty, that's the foundation of what you need to know for lesson 5.2. If you want to see some extra examples, some bonus examples here that you can walk through, you should walk through and try, and then if you don't get the answers correct, watch me do them here in this video. Okay? Alright, so if you want to pause the video and work through these, you can. If you want to keep playing, we'll walk through these together. Otherwise, I will see you. If you're going to go ahead and just fast forward, I will see you in class tomorrow. If you're going to keep watching, we'll go ahead and walk through these here.